Solve the rational inequality. Now this rational inequality is a really nice one because it's already compared to 0. That's the first objective for harder ones, is to get to this form. Express your answer using interval notation. Okay, so first off, we would want to factor everywhere we can. In this case, the numerator and denominator factors. The numerator, we would have x minus 3 times x, let's see, that would be plus 3, and x minus 4. And let's check that with FOILing. X squared minus 4x plus 3x is minus x, and minus 12. Perfect. The denominator is a little safer. It's just a difference of squares, x plus 3x minus 3. But again, we could check that. X squared minus 3x plus 3x is 0. You don't see the 0 one. And minus 9. Now you might notice that the x plus 3 reduces, but don't do it. What we want to do is find out when this expression is less than or equal to 0. So one by one, I'm going to look for any x-intercepts and any divide by 0 errors. And I see negative 3, 3, and 4 as the values that cause either the numerator to be 0 or the denominator to be 0. I can then go through, and the negative 3 is from the denominator. Make sure that you don't include that in your answer. That's a divide by 0 error. The 3 is also from the denominator. Don't include it. The 4 is from the numerator exclusively. Because of the equal sign, if I use x equals 4, I will get all the way through, I would get 7 times 0 over 7 times 1. That's 0. That's one of my solutions because I can be equal to 0. So if you have an equal in your inequality, any x-intercepts that are purely x-intercepts are included. The minus 3 is also in the denominator, so it's a divide by 0 error. As far as the graph, it would be a whole. Still not in the domain though. Now that we have those numbers on the number line, we want to go through and test the intervals in between each of these critical numbers. And I'm just going to do sign analysis for this one. So when I plug in negative 5 plus 3 will be negative. Negative 5 minus 4 is negative. Negative 5 plus 3 is negative, and negative 5 minus 3 is negative, and 4 negatives makes a positive number. 0, plugging in 0, we can see we'll get positive, negative, positive, negative. 2 negatives make a positive. 3.5, positive, negative, positive, positive. Again, 3.5 right there. 3.5 minus 3 is positive. Hopefully this is making sense and you're tracking this. Positive, negative, positive, negative. One negative is a negative. And finally 10, positive, 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 all across the board. That's a positive. Great. What are we looking for? Less than or equal to 0. The negatives. We now know that our answer is the interval from 3 to 4. We've already determined 3 is not included and 4 is included. And that's a fully justified solution for this rational inequality. All right, I hope this helps.